Example number 1, this first page, we are just solving trig equations. To begin solving example 1, you first want to add 1 to both sides. Then let's divide away the 2. Now we can solve, and it's up to you how you'd like to solve. If you traditionally like to complete a unit circle, you can do it that way. You can also use the trig chart. You would just have to find, if you use the unit circle, you'd have to find where in the unit circle do we have a sign value of positive 1/2. Now I'm going to be using the trig chart for these. If you're going to use the trig chart, first figure out which column, 1, 2, or 3, has a sign value of 1/2. That would be this column here. That's the pi over 6 column. I'm going to write down pi over 6 twice, because there are 2 quadrants where sign is positive. Oops. Okay, then we have this. Remember, all students take calculus. This tells you what is positive in which particular quadrant. In quadrant 1, all things are positive. So pi over 6 would be our first answer. In quadrant 2, only sign is positive, and as long as you know the denominator in quadrant 2, the numerator is 1 less than that. So 5 pi over 6 would be the other answer. Example 2. Let's start by adding 1. This one's pretty similar, except for one detail. First add the 1, then divide the 2. Sine of 1/2 x plus 1/2. Now, other than this 1/2 here that is being multiplied to the x, this is the exact same problem. We would start this the same way that we did the other one. Once we have isolated sine of x, we can now figure out where in the unit circle do we have a sign value positive 1/2. We've already established that's at pi over 6 and 5 pi over 6. Now, if we have something here that's being multiplied to the x or divided or whatever is with that x, set it equal to your answers. And now in order to solve, we have to multiply both sides by 2. Giving us 2 pi over 6 or pi over 3. That's our new answer here. Over here, multiply both sides by 2. That would give us 10 pi over 6 or 5 pi over 3. That's the difference between example 1 and 2. Example 3, I'm going to start by adding sine of x over. So we have sine of x plus sine of x plus root 2 equals 0. Okay, now I want to add these 2 common terms. Sine of x plus sine of x is 2 sine of x, and I'm going to subtract over the root 2. Now we can divide both sides by 2. Sine of x equals negative root 2 over 2. So let's go to our trig chart. Which column has a sign value of root 2 over 2? That is the pi over 4 column. So let me write down pi over 4 twice. And now let's figure out where is sign negative, because we need it to be negative root 2 over 2. That's in quadrant 3 and in quadrant 4. And in quadrant 3, as long as you know the denominator, the numerator is 1 greater than that. And in quadrant 4, as long as you know the denominator, the numerator is twice that, subtract 1. Those are your answers. Problem 4, add 1 to both sides first. Divide both sides by 3. Square root. If you're solving an equation and you use the square root method, remember it's plus or minus the result. Now we have to rationalize the denominator here. So let's multiply the denominator and numerator by the square root. That would give you plus or minus root 3 over 3. So go into our trig chart. The column where tangent is root 3 over 3 is here. That is the pi over 6 column. Now this time we're going to have 4 answers. Because it wants all the values where tangent is positive root 3 over 3 and negative root 3 over 3. Okay, here all values are positive. That takes care of the pi over 6. In quadrant 2, the numerator is 1 less. In quadrant 3, the numerator is 1 greater. And in quadrant 4, the numerator is twice the denominator. Subtract 1. Example 5, let's start by factoring out a cotangent. Once you factor out cotangent, that's what we're left with. Now we're going to set both of these factors equal to 0 and solve. This one here, we can go ahead and solve. If you don't know what radians produce a cotangent value of 0, well, let's use reciprocals here. We're going to flip cotangent to tangent, meaning we got to do the reciprocal here, which would be undefined. Now, your trig chart's not going to help you here. You would need to know where is tangent undefined in the unit circle. That's our quadrant angles. That's going to be at pi over 2. Oops, why did I do that? Pi over 2. And 3 pi over 2. So there's answer 1. There's answer 2. Now we can begin solving this problem here. First, add 2 to both sides. Square root both sides. Okay, now we need to do reciprocal here. The reciprocal cosecant is sine plus or minus. The reciprocal of root 2 would be 1 over root 2, meaning you have to rationalize the denominator. And if you do that correctly, you would get root 2 over 2. Looking at our trig chart where sine is root 2 over 2, that is the pi over 4 column. We're going to need 4 answers here. We need to know the radians that produce positive root 2 over 2 and negative root 2 over 2. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Example 6. We're going to need to factor this one. We need the factors of number in front times number in back. They've got to subtract to get -1. And now we're going to create a group ring problem. This is one way you can do it. Out of that group, let's factor out a sine of x. Out of that group, we can factor out a -1. Okay, now if we set each of these factors equal to 0 and solve here, for the first parenthesis, you'd have to add 1 to both sides. And in the second parenthesis, you would have to subtract 1, divide 2. All right, where is sine +1? That's a quadrant angle. That is at pi over 2. Okay, in order to answer this one, we can go to our trig chart. Sine is 1/2 in the positive, in the pi over 6 column. Write that down twice. Now, they want sine to be negative, so we go to our all students take calculus chart, and sine is negative in quadrants 3 and quadrants 4. Now, if you'll notice up to this point, we've just been solving equations much like we have since Algebra 1. With example 7, we're going to have to use some substitution because this looks like a factoring problem, and we would have to factor this problem. But we can't do it in its current form because we have sine and we have cosine. So we're going to have to do something a little bit different. This is where knowing your Pythagorean identities is going to come in handy. So are you aware of what sine squared is also equal to? sine squared of x is equal to 1 minus cosine squared of x. So by doing that substitution, we can now attempt to factor this problem. First, you'd have to distribute the 2 throughout the parentheses. And I want to combine these like terms right here. And before we factor, remember, you want your leading coefficient to be positive. So I'm going to divide all of this by a negative. And now we can start factoring. So the factors of number in front times number in back. They must add to get -3. So -1 plus -2, that's -3. And now we can begin factoring. Here we can factor out a cosine of x. Here we can factor out -1. If you set each of these equal to 0 and solve, this is what you get. Okay, so where in the unit circle is cosine 1? That is at 0 radians. Also 2 pi radians, but they don't want 2 pi as an answer. Everything from 0, including 0, all the way up to 2 pi, but not including 2 pi. That's what it's stated on the very top of this worksheet. Okay, cosine of 1/2. Here's your trig chart. Cosine is 1/2 here. That is the pi over 3 family. So let's write down pi over 3 twice. Cosine is positive in quadrants 1. And then in quadrant 4. Example 8, divide both sides by 2. Zero divided by 2 is 0. Now cosine is 0, those are quadrant angles, at pi over 2 and 3 pi over 2. Now we're going to take these answers here and we're going to set it equal to 3x. In order to solve for x, I'm going to multiply both sides by the reciprocal, 1/3. Those are your answers. Example 9, let's divide, not divide, I'm sorry. Let's subtract 3 from both sides first. Now divide away 3. Okay, in our trig chart, tangent is 1 in the pi over 4 family. Tangent is negative in quadrants 2 and in quadrants 4. Okay, we're now going to take both of these answers and set them equal to x over 2. In order to solve, multiply both sides by 2. There's your answer. And then over here, if we multiplied both sides of this equation by 2, we get x equals 14 pi over 4, which is 7 pi over 2. Yes, that is the answer we got, but it's not going to be a solution to this problem because 7 pi over 2 is greater than 2 pi. It only wants answers from 0 to 2 pi. So your only answer here is 3 pi over 2. Example 10, factor out a tangent. Okay, let's set these factors equal to 0. This one we can go ahead and solve. Tangent is 0. Those are quadrant angles at 0 and pi radians. Here we have to first subtract the 1 from both sides of the equation. Tangent is 1 in the pi over 4 column. And we need our tangent value to be negative. So that's going to take care of quadrant 2 and quadrant 4. Those are all your answers for example, whatever number that was. I don't even know. All right, here we have 11, I believe. Yes, 11. Start by adding 2 sine x, cosine x, both sides. Hopefully now you can see we could factor out a cosine. Okay, now we can set these factors equal to 0. And now we can begin solving. All right, cosine is 0 at pi over 2 and 3 pi over 2. Solve this one, you would have to subtract 1, divide 2 from both sides of the equation. Trig chart time. Sine is 1/2 in the pi over 6 column. And we need sine to be negative. So sine is negative in quadrants 3 and quadrants 4. Those also. Let's take a look now at example 12. Let's add 4/3 to both sides. Now we can square root both sides. That would give us, oops. The square root of 4 is 2. I was about to put the square root of 2. That is not correct. Okay, the square root of 4 is 2 over root 3. Now we have to use reciprocals here. The reciprocal of cosecant is sine. The reciprocal of 2 over root 3 is root 3 over 2. We're going to have 4 answers here because we need the values where sine is positive root 3 over 2 and negative root 3 over 2. Sine is positive root 3 over 2 here. That is the pi over 3 family. Let's write that down. 4 times. Here's your answer for quadrant 1, quadrant 2, quadrant 3, and quadrant 4.